Okay, so we're going to move on to factoring a difference of two squares. This is a different special pattern than the perfect square trinomial we were seeing before. So how can you factor the difference of squares using a pattern? So the difference of squares is when you have a squared term and you're subtracting a squared term from it. That's the difference of two squares. Well, when we factor that, a plus b times a minus b, that is the factored form. And we knew with multiplying the sum and a difference that it multiplied into this, square of the first term minus the square of the second term, and now we're working backwards with that same pattern. All right, so what is factored form of x squared minus 9? So it just has two terms, so maybe it's a difference of squares. So we're going to check that. Are we squaring something to get x squared? And yeah, we're squaring an x. Are we squaring anything to get a 9? 3. And is there subtraction? Are we finding a difference? And yes, that means this is a difference of squares. So factored form is going to have the sum and the difference, x plus 3 times x minus 3. All right, I'm going to skip over B and come back to that because I want to do part C first. So part C, are we squaring anything to get x squared? What do we square to get 64? And are we finding the difference? Yep, that's a difference of squares. So that means it will factor into that pattern the sum, x plus 8, times the difference, x minus 8. And that is our factored form. Part D, I want to move to that one next. Do we square anything to get a 9x squared? And because 9 is a perfect square, 3 times 3 is 9, we square a 3x to get 9x squared. Do we square anything to get 100? Yep, 10 squared. And we have subtraction, so that's a difference of squares. That will factor into the sum times the difference, so 3x plus 10 times 3x minus 10. All right, so this one I was skipping over, 4x squared minus 8. So it's two terms. Is this a difference of squares? Are we squaring anything to get a 4x squared? Yeah, 2x times 2x. Are we squaring anything to get an 8? And when we look at that, we would say, no, we're not. So I'm going to say, is this a difference of squares? Not yet. Because what I do notice is 4x squared and 8 have a greatest common factor. They have a GCF of 4. And honestly, we probably should have looked for that first to see if we could factor that out. Well, if we factor a 4 out of our problem up here, 4x squared minus 8, that leaves us with x squared minus 2. Now let's see if this is a difference of squares, because maybe we can keep factoring. Do we square anything to get that term? Yep, an x. Do we square anything to get a 2? No, we do not. So that means that this is not a difference of squares and we cannot factor it.